If we have two lines which are intersecting each other, is it possible to find the equation of any other line which passes through them, that is, passes through the point of intersection of these lines so that the three lines are concurrent? Yes, it is. And here is how it is done. Lines through the intersection of two lines. The diagram is shown for your benefit. The equation of the family of lines passing through the intersection of the lines a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0 is a1x plus b1y plus c1 plus lambda into a2x plus b2y plus c2 is equal to 0, where lambda is a parameter. So therefore, we have the two lines a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 intersecting somewhere, see at this point, and through that point there is another line shown by the dotted line. Now how do I find the equation of the dotted line? Now of course, for that we require an additional condition, but then it is possible to find the general structure of this line, and if we know one more geometrical condition about the dotted line, then we can definitely write down the equation of the dotted line as well. But then at least to start off with, we can say that the equation of the dotted line will be of the form a1x plus b1y plus c1 plus lambda into a2x plus b2y plus c2 is equal to 0. If the point P, 5, lies on the line parallel to y-axis and passing through the intersection of the lines 2 a square plus 1x plus by plus 4 a cube plus a equals 0 and a square plus 1x minus 6 by plus 2 a square plus a equals 0, what's the value of P? Is P given in terms of a like this, that's 3a minus 2a minus 3a or plus 2a? So we have seen in the previous section that if you have a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, a line passing through the point of intersection of these points is given by a1x plus b1y plus c1 plus an arbitrary constant lambda times a2x plus b2y plus c2 equals 0. So therefore, doing the same thing for our question here, we get a square plus 1 into lambda plus 2 plus by into 1 minus 6 lambda x plus 2 times a cube plus a times 2 plus lambda equals 0. So therefore, this is the equation, the general equation of line passing through those two lines. That is the point of intersection of those two lines. It's been given that it's parallel to the y-axis. If it is parallel to the y-axis, it will not even have a y term. The coefficient of the y term will become 0. Since it is parallel to the y-axis, its coefficient of y equals 0. So 6 lambda, that is 1 minus 6 lambda equals 0. So you get lambda is equal to 1/6. What next? Okay, substituting lambda is equal to 1/6, we get a square plus 1 into x plus 2 times a cube plus a equals 0. So this gives us a square plus 1 times x plus 2a into a square plus 1 equals 0. And so we get x plus 2a equals 0. That is, x is equal to minus 2a. So x is equal to minus 2a is the equation of the line. Now the point P, 5 passes through this point, and therefore P plus 2a is equal to 0, thus giving P is equal to minus 2a. And this is the value of the arbitrary constant P. And so we get option B as the correct answer to this question. JEE Mains 2015 had a beautiful question on reflection. Let's look at that now. Locus of the image of the point 2, 3 in the line 2x minus 3y plus 4 plus k into x minus 2y plus 3 is equal to 0 is what? So it's going to be one of these circles or straight line, whatever. So first, we will look at the line that is given. It is clearly given in the form of the family of lines passing through the intersection of the lines 2x minus 3y plus 4 equals 0 and x minus 2y plus 3 equals 0. So let's find out where these lines intersect. So it's basically that this is 2x minus 3y plus 4 is equal to 0. Suppose this is the line x minus 2y plus 3 equals 0. So therefore they intersect at some point. Let's call this point A. And then there is a straight line which passes through this intersection. And then there is the point 2, 3 and its reflection alpha, beta. So first we need to find the point A. And then what do we do with that? Of course, the point, say P, it's given as 2, 3 and its reflection Q. If the dotted line is the mirror, then since point A lies on the mirror, the distance of the point A from P and the distance of the point A from Q is going to be equal to each other. So therefore, let's solve the equations. 2x minus 3y plus 4 equals 0 and x minus 2y plus 3 equals 0. So we get, multiplying the second equation by 2, we get 2x minus 4y plus 6 equals 0. And so we get from this y is equal to plus 2. Substituting in any one of the equations, we will get x is equal to plus 1. So the point A is 1, 2. And so, since A lies on the line mirror, therefore distance of the point P from the point A equals the distance of its image from the same point. So therefore PA square equals QA square. So 2 minus 1 squared plus 3 minus 2 squared equals alpha minus 1 squared plus beta minus 2 squared. So we get from this alpha minus 1 squared plus beta minus 2 squared is equal to 2. So in the place of x, if x equals alpha and y equals beta, we get x minus 1 the whole square plus y minus 2 the whole square equals the square root of 2 the whole square. What is the square root of 2? The whole square, it is 2. So therefore, we get this equation of circle in the center radius form. And thus the required locus is a circle of radius root 2. And so we will get option A as the correct answer.